We are always pushing the boundaries of science for new ways to heal our patients. We spent the 20th century searching the world for cures when the next great frontier was right here all along. 21st century medicine will deploy the body's own cells to fight disease. We will also engineer cells to heal and regenerate tissues. Right now, scientists at UCSF can program immune cells to ramp up our body's fight against cancer. These cells, not unlike robots, can recognize, hunt, and kill disease cells and cancers that were lethal just a few years ago. These techniques aren't just short extensions of life. For many, these are full cures. Here's how cell engineering works in cancer. T cells are the armed guards of our immune system. They jump into action when they detect invaders that make us sick. Meanwhile, cancer cells are masters of disguise and often escape notice. Scientists gather a patient's T cells, genetically program them so that they make a receptor that can recognize certain molecules on the surface of a cancer cell. Then they put them back into the patient. The engineered T cells dart directly to the disease cells to identify them. The first priority is making sure that no healthy cells are harmed. The T cells are engineered to use a two-step authentication process for identifying cancer cells. If the first receptor can't find a match, the cell goes unharmed. But when the first receptor does find a match, it triggers the creation of the second receptor that recognizes another molecule. If both receptors connect, it is a confirmed cancer cell, and the T cell will kill it. Meanwhile, the engineered T cells can also send signals to and engage other local immune cells in the fight, joining forces to kill the disease cells. Healthy cells and tissues go untouched, a far cry from the scorched earth effects of chemotherapy, and a safer and more effective cure for cancer. But the promise of cell engineering extends far beyond cancer. Cells could be engineered to halt the degeneration seen in neurological disorders like Parkinson's and dementia. They could be trained to recognize damaged islet cells of type 1 diabetes and protect them so they can produce insulin. Stem cells could be programmed to repair tissue damage in congenital heart disease and spinal injury. They could turn down the immune system only at the site of a transplanted organ to avoid rejection. Using cell engineering, UCSF scientists will orchestrate the body's own ingenious powers of fighting disease, healing, and regenerating tissue. It is the millennium's most astonishing paradigm change.